All right.
Hello.
All right, that's Isla. All right, anyway. So with this one, make sure you know the definitions that we just did there, especially the definition of a sphere. Know what it means by great circle. Guys, and also remember to understand that a diameter, very simple for us to get to, all right, by just doubling the radius. And of course, going the other way around. Are you guys with me on that so far? All right, so let's make sure that we have all of that stuff down. But now we're just doing the surface area and the volume of spheres. They're very simple formulas. Again, remember, we can't have lateral area because there is no base. Now, back up for a moment. Can I find the lateral area of a hemisphere? Because would I have a base? Yeah, it would be the great circle. So think about it. A hemisphere and a sphere don't always have the same type of relationship, so be very careful. Now, this is one of those times where I wish I was a really cool teacher and would have remembered to bring a clementine with me to school. All right, the clementine, is it basically a sphere? Right? You can have an orange would do the same thing, but clementines are easier to peel, so I can use a clementine easier. So if I was taking the clementine, I would literally trace around its outside, and if you trace around the outside of it, wouldn't you create the great circle? All right, and I'd actually trace it 4 times. So imagine that I have this clementine, which I guess this green sphere I'm holding in my hand might be close enough. And I go around and I trace it 4 times. And now, then I start peeling it in front of you, because none of you would be hungry, you'd be okay because you all ate lunch, right? And I'd start putting it, and I would just start placing all the pills inside the circle. And you'd keep going, you know, all the weird shapes. And I'd fill up one circle, I'd keep pilling, I'd put it in the other circle, and I'd keep pilling, and eventually I'd fill up all 4 circles. Like if the clementine, orange, anything like that, that type of shape. You wouldn't go outside of that. You'd always be on the inside of those 4 great circles every single time. In fact, if you're really cool, it'd like fit perfectly, but I'm not really cool in showing that. But that's the idea behind it. So think of the pill of the clementine as your surface of your sphere. How many of those circles did it take? 4. So basically, if I knew the area of a great circle, should I be able to find the surface area of this, right? And so you do. It's just the surface area is 4, I don't think I can get, I got it fit in there. It's 4 pi r squared. Well, where did the pi r squared come from? Well, the pi r squared is the area of your great what? The area of your great circle. So you really could sit and say your surface area equals 4 times area of the great circle. And remember how we do notation of a circle? You literally put a circle with a center in it when you're talking about it. So every single time, like if you're ever bored someday, you could actually do that with an orange or, you know, clementine. Like this summer when you're like nothing else to do or have a snack, you can try that on your own. All right, I can just see you guys sitting there like, oh, Gregerson said to do this. I don't see that happening, but hey, if you're bored, it's an option for you. All right, so that is going to be your surface area formula. So 4 pi r squared. Guys, here's how easy this is to remember. What do you do to your radius? Square it. So make sure you have a squared label. But notice for volume, I never talked about height at all when I talked about your sphere. The only thing I talked about was the radius, because that's the only thing you need. Your volume for a sphere is 4 pi r cubed all over 3. So it's 4 times pi times the radius, but what do I do to the radius? Cubed it all over 3. Or you can write it, let's go or this way, we'll go backwards. Or you could write it as 4/3 pi r cubed. Only reason why I use the one on the left, I prefer the one on the right, but the one on the left is if you ever have like a fraction for the radius, wouldn't it make sense to use the 4/3? It's nicer math that you're working with. So a lot of times just make sure you cube it. Guys, this is just 2 formulas. Remember, surface area and volume. You do not have to know lateral area for a sphere. What do you guys think? Pretty easy? Right? All right, let's have some bless you. All right, let's do this one real quick. It says find the surface area of a sphere with a diameter of 76 centimeters. All right, first things first, write down your what? Formula. What is your surface area formula? Yeah, 4 pi r squared. All right, excellent. What do I need to know? Yeah, I need to know the radius, correct? So to find the radius, don't I have to take the diameter and divide it by 2? All right, so 76 divided by 2. Make sure you have your calculators out. We're still going to need them. It'll be 38. Okay. Now plug and chug. Directly below your formula. I got 4 pi. I'll put my radius in there. It's 38 squared. Someone punch that on your calculator. Pi will come along. What'd you get? It should be pretty large like that. I just don't have it off the top of my head. All right, sounds good. 5,776, right? Yeah, 5,776 pi. And this would be, since it's area, square centimeters. Guys, there was several of you on the quiz that lost about 3 or 4 points alone because they mislabeled lateral area and surface area by cubes. And that was more than one person in this room. Remember, surface area is squared, volume is what? Cubed. So be very, very careful with your labels with these. All right, guys, isn't that easy? All right, how about the next one? It says find the surface area of a sphere with a great circle that has an area of 49 pi square miles. Okay, 49 pi square miles. Scholars, do I need to use this formula? Yes or no? What do you guys think? No. Why don't I need to use that formula? I already got my what? I heard you, several of you said, I already have my what? Area. Yeah, I already have the area of the great circle. So couldn't I just go like this? Notice I still wrote the formula down because really that's 4 times the area of that great circle. But I'm not going to solve for the radius if I don't have to. I don't know about you. A little bit less work is a little bit more the way I want to go. Thank you, ma'am. Thank you. All right, what'd you guys get? 196 pi, and that would be in square miles. Are you guys good with that? Good? Awesome. Isn't surface area easy? Yes. All right, you guys do the last one because everyone should ace this one. Go for it. Find the surface area of the sphere with a diameter of 68 millimeters. Who's got this calculated for me? Was 34 squared times 4. It should be pretty large. Joseph, what did you get? 4,624. What comes along? Pi. Notice I didn't tell you which one. If I don't tell you, give me exact form. So 4,624 pi square millimeters. Kind of large, but we can handle that. Okay, that's how easy this is. At least I feel like it's kind of like working with cones after working with everything else, right? So much easier. All right, so work with this. Let's talk about the volume of a sphere. It says find the volume of the sphere, give your answer in terms of pi. Okay, what's the volume formula, guys? Yeah, 4 pi r cubed over 3. All right, so I need radius. Do I have radius? No. Can I find radius? Yeah, because my diameter is 24. So our radius is what, guys? Yep, should be 12. A lot of you don't have to show the work for that. You should know it. Plug it in, we get 4 pi times 12 cubed over 3. Now, looking at this, you could possibly have fractions for answers, right? Here's how you know if there's a fraction for an answer or not. Look at your r. Is it divisible by 3? That means no fraction. If it's not divisible by 3, then you're going to be like, great, improper fraction for an answer. So that's an easy way of checking. So if you guys could do that for me, what's 12 cubed times 4 divided by 3. What did we get? You said 2,000? Did you get, I think that's right, but I have to double check real quick. Double check my math here. What do we get? 12 cubed times 4 divided by 3. Oops, don't use what I just did on my calculator. 3 times 4 divided by 3. 2,304?
Yep.
Yep. I accidentally punched all into exponents. It went crazy on here. All right, 2,304 pi cubic inches. Are you guys good with that? Are we good? Not good? Good. Fantastic. All right, you guys do the next one because this easily could show up on your test. Find the volume of the surface area of Make sure you show your work directly below your formulas. Some of you still have to get in the habit of actually writing your formulas down, right? Make sure we show it. Nick, what did you get for the surface area? Got your phone? I can give you a different calculator. I'll even exchange calculator for calculator and charge that during class. I'll help you out. All right, help Nick out since you didn't have a calculator, guys. What did we get for the surface area? What'd you guys get? For the surface area, though? Shouldn't it be 256? Because it's just 64 times 4. So 256 pi square centimeters. Now, your volume, we have to plug this in. We have 8 cubed all over 3. Guys, are we going to have a fraction this time?
Yeah.
All right, so here's how easy it is. If you know it's going to be a fraction, leave the 3 in the denominator and just do the math on the top. What's 8 cubed times 4? Here's the thing. You need to make sure you either write it as 4, parenthesis 8, parenthesis cubed, or do the 8 cubed first and then multiply by 4. You got to do order of operations, exponents first. Otherwise, numbers come out wrong. What do you guys get? It should be pretty large. So 2,048 pi, isn't that going to be in cubic centimeters? And it is a fraction for that. What do you guys think? Guys, some of your problems are going to have this as a fraction. All right, keep working with me on this. All right, I want to find the volume of a hemisphere. What would I do? Yeah, isn't it going to be the half of the volume of a sphere? So basically, I know the volume of a hemisphere equals 1/2 volume of the sphere. Basically what we're going to be doing. So can I go 1/2 of 4 pi r cubed over 3? You could leave it like that, or could I go ahead and multiply by the 1/2 first? What do you guys want to do? Do the first part?
In the parentheses.
That's totally fine. You can do that as well. You'd get it right. So let's do inside the parentheses first. So I get 4 pi. Your radius is 15 cubed all over 3. So someone said do inside the parentheses first. Fine, because that's the volume of a sphere, right? So with that, what did you guys get for that? We have our 15 cubed times 4 divided by 3. Did you guys get 40? Is that 4,500 pi inside of here? Okay. Guys, what's 1/2 of 4,500? Yep. Very good. 2,750 or 2,250? All right. 2,250 pi cubic meters. Could you just go ahead and calculate the volume of the sphere by itself and then just divide by the 2 at the end? Yes, that would also work, and it would be good. What do you guys think? So far, pretty simple? All right, make sure if you don't have a calculator, you need one now, all right, for this next part. Because the next part is a work backwards problem, which I know everyone loves, right? When you work backwards, we know we have one of the end results, either of surface area or volume, and we're looking for a missing part. Here it says, find the surface area of a sphere with a volume of 2,304 pi cubic feet. I know volume, but in order to solve for surface area, don't I need radius? So do I have to work backwards to solve for the radius? So I'm going to start with our formula, because we know this. It's 4 pi r cubed all over 3. So then we go 2,304 pi equals, actually I'm going to move it down a little bit so I have a little more space. 2,304 pi equals 4 pi r cubed all over 3. Okay, algebra wise, how do I solve for the radius cubed? Multiply both sides by what? 3, okay. So that's going to end up being 6,912 pi is equal to 4 pi r cubed. Does everyone understand what I just did to both sides of the equation? Guys, I'm to the point in this world, and this in your math career, that not every step is always going to be shown. But I want to make sure. Did you understand what I did to both sides? Are you certain? Okay. Now, how am I going to get the radius cubed by itself? What am I going to divide by? I'm going to make sure I divide by 4 pi. What happens to the pi's? Anything divided by itself gives you what number? 1. So it's gone. All right, so those simplify out. Slash them out if you want to. And then go for me, please, and go 6,912 and divide that by 4. 1,728 equals my radius cubed. Now, does anyone know how to take the cubic root? If I had a square root, it'd be easy. We'd just take the square root of both sides. Guys, when you see a cubed or to the 4th, you do the same thing. I just take the cubic root of both sides. And this is what it would look like. And you're just going to write this down, but I'm going to show you how to do it on your calculator. Are you guys good with that? So I have the cubic root is you take a square root symbol and you put this little superscript off into the corner, kind of like in the crack of the square root symbol, okay? And you put 1728 in, and then I'm going to take the cubic root of my radius cubed. I have to do it again to both sides. But the thing is, not every one of you have your perfect cube numbers memorized. Like you don't have 8, 27, right? 64. You don't have those memorized as your perfect cubes. So wouldn't it be nice if your calculator can do it? Oh, people, your calculator so can do it. All right, so pull up your calculator here. I'm going to clear it real quick. Clear one more time. All right, so how do I do this? All right, well, here's how easy it is, guys. Go to math key, which is right below your alpha key. Go math. Do you see number 4? Just hit the key number 4, arrow down, and there it shows up for you. Does it all for you? All right. All right, hold on a second. Let's clear this out here. Make sure everyone's on the same page. All right, go math key. Which number, if I go math key? 4. And then put in our value. What is our number that we have there? 1728? 1728. Hit enter. Isn't that cool? Now here's the cool thing. Notice I didn't put a plus or minus in front of it because you can have negative numbers that are cubed. Like a negative times a negative times a negative is a negative number. So you don't have to worry about that when you have cubic roots. You don't have to worry about it when you have square roots. So the cool thing is you can plug it in. You can have negative numbers underneath the radical sign now. It's all cool. So with this, you're going to get 12. Now can I just punch that into your surface area formula? Isn't that cool? So your surface area is going to be 4 pi r squared. So 4 pi 12 squared. What's 12 squared? So 144 times 4. Okay, good. I was thinking that correctly in my head. So 576. So 576 pi square feet. Isn't that the coolest? Now, you will have to do, I think, I'm looking at this, I'm looking at the notes. I don't think you're going to have to work backwards. I just wanted to show you that. But can I stop for a second? This is a sidebar that was not in the notes, but I want to make sure. Did everyone see all the cool features on your math key there? This lets me convert decimals to fractions, fractions to decimals. It lets me cube things. Takes the cubic root. Obviously, notice the number 5 there. That's when you have like a 5th root, 6th root. Don't worry about that until Algebra 2. But that's the type of stuff you can do. Isn't that kind of cool? All right. So just to understand, that's a powerful key on your calculator. All right, let's do a last work backwards problem here for the moment that we can at least get through here. All right. So it says, find the volume of a sphere with a surface area of 900 pi square centimeters. Can I work backwards with surface area this time? Yeah, because I know my surface area, I want to find volume. I still need to know radius. So my surface area formula is 4 pi times radius squared. So I get 900 pi is equal to 4 pi radius squared. How do I get radius squared by itself? Yeah, divide by 4 pi. All right, here's the easy part. What's 900 divided by 4? So I get 225 is equal to my radius squared. What do I need to do to both sides? Square root, right? Don't cubic root. This would be bad, right? Square root it. So I take the square root. Yep, it's going to end up being 15. Excellent, because radius needs to be a positive length. So the radius is 15. Can I take that and plug it into my volume formula? Because remember, where do I want to go? I want to solve for the volume. So this part is really nice. We just plug it in. Write your formula down. Put your work directly below. Guys, will I have a fraction for an answer this time? Nope, you shouldn't. So someone punch that in real quick. This should be very similar to a problem that we've done in the past here. What do we got? Yep, should be 4,500. What's going to come along? Pi cubic centimeters. What do you guys think? Not too bad? All right, guys, do you think we have time to do that last one? I think we do. I think we can do it. We can actually have finished notes. Hold on. We can do this. All right, it says find the volume of a sphere with the surface area of 324 pi square inches. Is this another work backwards? Yeah, this time I'm starting with surface area again. So we get 4 pi r squared. So I can go 324 pi is equal to 4 pi r squared. What do I divide both sides by? All right, so what are you going to get? Do it with pi as well. What do you guys get? 80 what? 81. So equals radius squared. Can we take the square root of both sides then? But what's the square root of 81, guys? 9. Then you just have to plug and chug it into your formula. Now, guys, I'm warning you right now. Homework is going to be uglier than notes. You're going to have fractions and stuff like that you're going to have to work with. So just warning now, it's not going to be pretty. I know, it's not what you wanted to hear. So just know it's going to be a little bit rougher, but you guys can do it. What'd you guys get for the volume for this one? Pi cubic inches, right? Excellent, guys.